Good day, everyone. We are Group 5 from MECC 481 P1C2, and we will talk about probability and statistics problems. Together with me are Alvarez Francis Paul, Gomediano John Ray, Campos Joseph Victor, De Los Reyes Tom Jules, Martizar Ayan, and Saga Jan Allen. So the first problem would be Maria has the probability of hitting the target at 2/3, while Mario has the probability of hitting the target at 2/5. They both fire at the target. Find the probability that one of them hits the target. So this kind of problem is a joint probability for non-mutually exclusive events with common outcomes. So by analyzing this problem, that we will get the probability that only one of them will hit the target. So it is equivalent to the XOR formula where Maria XOR Mario. So this XOR formula will be next. Is the probability that Maria hits the target plus the probability that Mario hits the target minus 2 times the probability that they will both hit the target. So by substituting all the given, for the probability that Maria hits the target, it is 2/3. And for the probability that Mario hits the target is 2/5. Then by calculating, we'll get 0.5333. So the next problem is determine the relative variability of the following data: 112, 132, 144, 156, 164, 176, 183, 197, and 200. So this problem can be solved by using formulas. For the formula for the mean, in which you will add all the values and divide it by the total number of total number of values, and you can use the standard deviation formula, but it will take time to solve this problem using those formula. So to solve this problem faster, you can use your calculator. You can set the mode of your calculator to stat or ST, then select one var or one variable, whichever is available in your calculator model. The next is to input your data in each row. For older calculator models, this may be done by inputting the value, then pressing M+. Then after you have inputted all your values, you can press Alt clear or AC after the final value. Then next, to obtain the values for the standard deviation and mean, you can click Shift 1 or Shift Stat, then choose var, and choose the standard deviation or mean symbol. Then after that, you can use the relative variability formula, which is mu is equal to the sigma, or this sigma is the standard deviation divided by the mean. And in the calculator, standard deviation is sigma x, and the mean is x bar. Then you can use this formula, input all the values, substituting, then you can get 0.172. The next problem. A ball contains 5 red, 3 blue, and 2 yellow balls. If you draw 3 balls, what is the probability that less than 2 will be blue if you draw with replacement? So the probability that we will get here is that we will get only 1 blue ball. Then it is with replacement, so we can use repeated trial probability. So this will be the formula for the repeated trial probability, which is probability is equal to n combination r times p to the power of r times q to the power of n minus r. So n here is the total number of successes in the population, which is 3. Then r is the desired outcome, or the desired outcome, or 1, because we need only 1 blue ball in the selection. Then p here is the probability of success, which is 3/10, because there are 3 balls. There are 3 blue balls. Then there are 10 balls altogether to the power of 1. Then q here is the probability of failure, or the probability that we will not get blue balls. So it is 7, because there are 5 red plus 2 balls plus 2 yellow balls. Then there are 10 balls together to the power of 3 minus 1. Then by calculating it, you can get 0.441.
So for the other problem is what is the probability of having at least a one girl if the couple has three children? So knowing that there is only one scenario where all children are boys and each case is independent of each other. So using with the formula of three boys is 1/2 for each boy. So the equal to be 0.125. And by complementary probability, for at least one girl minus for the probability of the three boys is 1 minus 0.125, and the answer would be 0.875. And for the next question is what is the probability of getting two heads if you toss a fair coin twice, knowing that the first toss resulted in a head? So since the first toss is guaranteed to be head and the probability to be considered is only for the second toss, so for the probability, second toss would be heads is 1/2. So the answer would be 0.5.
For the next problem, we have a Wheel of Fortune is divided into three equal parts. Each part is named 1, 2, and 3. What is the chance of landing on a 3 if you know the arrow landed on an odd number? Now, since it is guaranteed that the arrow will land on an odd number, and there are only two odd numbers, which are 1 and 3, therefore, we can split the chance between each number into 1/2 or 0.5, wherein the 1 has a 0.5% chance of being landed on, and 3 has a 0.5% chance of being landed on. And for our final problem, a mechanical engineering student is taking a 15 items true or false type examination. If the student guesses at the answers, find the probability that he gets a perfect score. Now, since the examination is only true or false, then the probability of getting a correct answer is 50-50 or 1/2 or 0.5. Now, knowing that there are 15 items or trials, all of which are independent of each other because the answering the second question correctly does not affect the third question, so on and so forth, we can simply get the correct answer by multiplying each instance or each chance uh, for each trial altogether, which will give us 1/2 times 50, times 1/2 times 1/2 times 1/2 up until 15 trials, or simply the probability of a correct answer raised to 15. So that's 1/2 raised to 15, which would give us a value of approximately 3.0517 57813 times 10 to the negative 5. So that is a very small chance of getting all of the questions correct if you were only to guess. So that is all for our presentation. Thank you very much and have a nice day.